I'll go to this next talk with Mr. T.C. Karthikeyan from Blue Star. So Karthikeyan is worked in past, now presently is in Blue Star, is previously is worked in BHL Trichy and Larsen and Toubro and Plus Veloci in Oman. Is the basically is PCN level 2 in ultrasonic testing, especially in advanced technique like paced array, TOFD, and radiography. Is also is holding this BRC level 1. Is working in this almost 14 years in NDT domain, and he has successfully demonstrated many advanced ND equipment, some major kind like BPCL, HPCL, MRPL, Chevron, Shell, ExxonMobil, and Aramco Saudi. So he has led that significant projects including L&T, Plus Veloci Oman, and the many such things. Actually, when I asked for his biodata, he has sent about 6 to 8 pages. I said, due to time constraint, I cannot read. Give me a little bit. So with this short, I welcome the young and energetic Mr. Karthikeyan, Blue Star. So over to you, please come.
A warm welcome from you all, from our Blue Star team and our Pallaki team. So just I will give you a crisp about the phase array. So what are all the implementation in the advanced technique and how we are doing in the industry, how it will reduce your time. So my presentation will be like. Yeah. So my presentation is about overview of about the phase array technology. So in our team, myself and Mr. Vijay Kumar and Abhishek Roy will be there. So basically, our ultrasonic testing will be the reflection technique. Just we will get the signals. With that impedance change, we can able to analyze the defect like this. So I will go a little bit fast to complete the schedule as with that I in the time. So it will be like that. So whenever we are transmitting the signals, we will get a reflection. In the impedance change, we will get the defect with the represent of echographical form. It is called radio frequency RF form. So after coming this, the phase array, it will be like a 2D view, same as like our sonography, what we are doing in the medical sonography. So I just give you an example for medical sonography and as well as what we are doing in the industrial phase array. So why the phase array? What is the advantage of phase array? So in normal ultrasonic testing, we will use only the single crystal probe, means to transmit the signals and receive the signals with the represent of echographical representation form. In here, we can able to get in the C-scan or D-scan like a graphical representations, and we can able to steer the beam whatever we require. Like these are all 3 types of steering capability with respect to phase array. So now advantages of phase array. What is the advantage of phase array? So the main advantage is for the better inspection and faster inspection. We can able to complete that and we can able to get a record on that and we can able to exactly, precisely identify the indication and size the indication. That is the main advantage of phase array. So this is the example of steering capability of phase array and normal our conventional UT and as well as the PAUT. So we can able to steer the beam and we can able to pitch and catch with respect to phase array. So it doesn't require much more skill. It requires some practice and level 2 certification. Then he can able to do the inspection. And the main thing is that to do the interpretation, it requires the skill to identify the defect and size accurately. So next one is that earlier the phase array was started like a 2D. Now it has came to the advanced, like our earlier sonography to the Doppler. So in here you can able to see with respect to this technique is called FMC and TFM. It's called the full matrix capture and total focusing method. So the data how it will look, you can see. So in here we are doing the TFM for the 100 mm thickness, and in here you can able to see the exact, all the indications will be on the depth wise and size wise, it will be same. So we can able to get the accurate sizing of in the TFM. So how FMC will work? So example, the phase array is like sum of element, quantity of element, we have to send the signals and we will receive it. And in here we will send the signal from the first element and receive from the all of the element. So and we will post process the data with respect to what required. Example like half skip or one skip, 0 degree or shear wave, means it's like a tandem technique. Whatever we required, we can able to post process the ultrasonic data which was recorded from the FMC that can be shown in TFM. So in here you can able to see the first element will pulse, rest of all the element will receive. So and it will create a data matrix. So the elementary scan will be stored in the recorded form of FMC. So and after second element, third element, fourth element like that. Suppose if I am having a 32 element, then I can able to get a 32 into 32, 1024 elementary scan. That all the elementary scan has to be recorded in the form of FMC. Then I can able to see what technique I required, like 0 degree I required or angle required, whatever required, I can able to view in the different form. So this will be like that. So now the FMC raw data has to store. So first element, second element, third element, fourth element like that. Then after, we can able to get the summation of the all the data, and the final output will be the defect signal with respect to exact sizing. So this is the sidle hole. So these are all in here we are having the different types of modes. I want to know go much more deep in that. It is like there are the two types of modes. One will be the pulse echo and another will be the self tandem. Pulse echo is like a one type of waves, like longitudinal to longitudinal or shear wave to shear wave. If you are going for another typical like longitudinal shear wave, then we will go for the self tandem techniques like our pitch and catch. So in here you can able to see with the TFM the signals will be very much clear. If you have a root crack, it will be shown as like a root crack only. So these are all the different types of modes which can be used. You can see the LF, it is very much clearly seen. If you have a single V, the LF will be placed, you can able to exactly size the height of the indication. So this is a typical example of phase array image and as well as the TFM image. So in here we have taken a cluster porosity. So with respect to the phase array, we can able to get a better identification on the TFM. So this is the another example of that. So and another thing you can able to notice that the initial pulse width is comparatively better than in TFM. So you can able to identify a near surface indication also in TFM very good. So this is another example how the scan plan has to be created. It doesn't require anything, just you have to select the probe, then you have to identify your location, it will automatically show the beam capability. So like that it is showing. So this is the root crack. So in here another one major difference in phase array and TFM is that suppose if an indication one beneath another, you will not able to get in the phase array or our manual ultrasonic testing. But due to the FMC, we can be able to identify the indication one beneath another. Example, if an indication is there, if another indication is there, I can able to identify both or twice the indications. So and I can able to exactly size even though the amplitude is also not much bad. So this is another one example for detection of HTHA crack with respect to TFM. So this is the stepwise cracking that was detected in TFM. So in here you can able to see the exact stepwise cracking as shown in the figure, it will be same. So it will be like a realistic image, means an operator can exactly see what is inside. So next one is that phase coherence imaging. So it is another post-processing technique with respect to the FMC. So the FMC data has to be collected and it can be shown in the form of TFM. Then another form is called phase coherence imaging. This technique is, example in our ultrasonic testing and the phase array is depend upon the reflection of signals. Means whatever the energy we are giving, that energy will be reflected and it will be showing that. But in here, it will not take the energy, means it will not take the dB form. It will take only the coherent signals. Wherever you are having a phase change or phase reversal, it will automatically post-process the data and identify the indication. It will show you. Means a technician has to go to the job, he has to connect the probe and set up his parameters, then he can do the job. If indication will be there, you can able to see on the screen. If indication will be not there, you will not able to see. So it doesn't require any calibration and all. So this is another example for the PAUT, TOFD, and the TFM and PCA. So in here you can able to see the better capability in PCA. So this is the signal processing, how they are doing actually. So what it will do, it will take only the non-coherent and coherent signals. Wherever the coherent signals will be there, it will automatically post-process the data and you can able to see in the screen. So this is another comparison for volumetric indications. It's the root crack. So another example for HTHA with respect to TFM and as well as PCA. So one thing you can be able to notice that in TFM we are having some noise signals in here, but comparatively with the PCA we can able to exactly identify the HTHA defects. So what it will do, it will means remove all the noise signals. It will only show the coherent signals only. So means wherever the defect will be there, you can able to see in the defect. So this is another example for HTHA. It's a typical HTHA, but you can able to see wherever we are using a reflection technique, we can't able to identify that much of sizing and all. But comparative with the PCA, we can able to better identify, means better capability of detecting the defects. So this is another H2S crack. So this is the equipment that we are performing with the advanced technique. It is called Omniscan X3. So these are all the different types of models which is available in the market. So the higher end is this Omniscan X3 64 model, 64 128, means it is having a 64 pulses and 128 receivers. We can able to simultaneously connect two probes with the capability of 64 element. So next one is the integrated TFM with the X3. So this is just we have taken in the blog. We are having a side reflectors on a radial basis. We can able to identify all the reflectors in the radial. So how the scan plan will be like in TFM or PCA, your scan plan will be like that. So you can able to exactly see my coverage and what the parameters has to be changed. We can able to easily change it. So in here we can able to see a plot graph of 4 palettes, like different 4 modes in the single screen. So means example, if I want to cover a weld, root, weld volume, lack of fusion and toe area. So all the parameters I can able to see in a single screen. So in here we can able to go a maximum aperture of 64. So this is just a means overview of how the scan plan has preparing for this TFM or FMC. So in here just I have to plot my groove and it will show you the coverage of what your thickness of the weld. So and another advantage is that we can able to reduce the dB signals and we can able to exactly size the indication. Suppose if an indication has crossed 250 or 300 amplitude, 300% amplitude, we can able to reduce it, and if a saturated signal also, we can able to reduce it and we can able to size it. So in here, with the help of this dual matrix array probes, in the equipment itself, we can able to simultaneously scan and we can able to skew the angle, means sound direction in active aperture and as well as passive aperture. Example, if I am having a probe, I can able to steer my beam in this direction. But with this DMA probe, I can able to steer in active and as well as passive. Means 15 degree tilt, 0 degree, minus 15 degree. So indication will be in any orientation. Suppose example, if a transverse indication will be there or if a longitudinal indication will be there, we can able to easily identify within a single scan. It doesn't require any multiple scans. So another one technique, as sir told, the AI has to be, means it's implemented in the market. So we have also implemented in our equipment, this is called RCS, Remote Control Systems. Suppose if I am having an equipment in India, just I want to train some persons in Saudi Arabia, so I can able to use the equipment as like a Zoom. So he can able to operate in Saudi, in my equipment is in India. So example, so I have connected a Zoom in my laptop, so he can able to control the equipment in Zoom. So just he has to give a link in the mail. So once he was connected, then he can able to operate with in the laptop itself. Now whatever changes he has done in laptop, that will be automatically implemented in the system. So with this we can able to connect more than 6 members in a single meeting. We can able to train the people on virtually also. It doesn't require any physical training. So and also this will be very helpful in on-site condition. Suppose in on-site condition a technician is working, so he is having some doubt, we doesn't require to go there. We can able to means given assistance from here itself. So the data compatibility, we can able to use all the older version data to the new equipment also. So it will be compatible. So this is the capacity of the equipment. We can able to use, earlier the storage was very difficult. Now the storage was enormously increased, and we are having our on-cloud system also. Suppose it doesn't require any storage data. We can able to store the data in a cloud system. We can able to retrieve the data in any time. So we can use both the technologies, like our older card version or USB version. And another system is that it is having a means OneDrive system also. We can able to store the data in the OneDrive, and we can able to connect the equipment with the Wi-Fi with the help of dongle. So means any software update will be there. Just we don't require to go to this website and all. We just click on that, it will automatically update it with the help of our Wi-Fi. So this is just a sizing of rescan. It doesn't require any. So the equipment is having a GPS capability also. Suppose if you are doing in a long conduit pipeline, so the client can easily identify that you are in which location you are doing, in what GPS coordinate you are doing. So the next advantages came in the phase array is that we can able to adapt a typical geometries like a T joint or K joint or Y joint directly into the equipment, and I can able to easily understand that where my signal is hitting, it is a geometrical echo or it is a defect echo. So this is an example for that. So these are all the different types of scanners which has been used in industries for typical inspections like corrosion mapping, weld inspection or automatic crawler inspection, or if you have any long chimney, you have to inspect it, we can able to inspect it, turbine inspections, wind blade inspections. So this, all the scanners has been having a different typical capabilities. So this is our software. The software is totally free with this equipment. You can able to download it, and the advantage is that you can able to use in a n number of PCs. Suppose if you have a data, you require a training, you can able to easily take a training with your data. So another software, it is called well-site software. In the well-site software, you can able to simulate multiple probes for multiple zonal discrimination, like our automatic AUT. So in here also you can do it, and it will, it doesn't require any dead element check. It will automatically do the dead element check. The software has been implemented in that, like, so to adapt the AI in future actually. So if we have collected the data, if the collected data can be simulated, suppose if I am having a pipe, the collected data has to be simulated exactly in the circumferential direction like a pipe, and I can able to exactly identify which clock location the defect is there. You can see. This is the example of that. Suppose he has collected the data, the data has been, it's a circumferential direction, we can able to make it. So example, this is the data that they have collected. In here it is a pipe, so you can able to see where the defect and in which depth it is there physically to give you a representation to our client very easily. So this is an example video of the software, how it works. You can able to see. Means I can able to move my gate and see the exact particular location of the defect also. And we can able to create a custom layouts like A scan, B scan, C scan, D scan, whatever all the forms I required, I can able to change it, I can able to view in the data. So now they have collected the two probe data, then they have simultaneously merged the data in a single data. So now they have merged the file. The two files has been merged in a single file. So suppose if I have done a zonal discrimination, like suppose I am having 100 mm thickness, I have done two scans for 0 to 50 mm and 50 to 100 mm, then I can able to merge the two data and I can able to easily view in a single data. That will reduce your time and it will be very easy for to identify the indication. So you can see. So this is the TOFD data. So after scanning, they have done the post processing, like the straightening of the lateral wave and synchronization of the lateral wave, like that. So these are all the some typical probes that we are using for detection of crackings, HTHs and all. So these are all the different typical probes we are using with TFM and FMC. So next, coming to the advanced solutions, what are the advanced solutions that now doing in the industry? So for fluxiform, it is for the pipe elbows, means bend. So next one is the hydroform technique. Wherever we are having a pipe, we need a corrosion technique. So we will use that. And this is the map scanner. It's like a chain scanner. We can able to move the scanner. So this is all the automated scanners which will automatically roll in the component or it will climb in the component and it will do the inspection, whether it is having a weld or if you are having a raw material. So these are all the typical industries nowadays they are using. So they are using in the pipes. These are all the different types of scanners that we are using in them. So this is the Cobra scanner for exchanges, for this superheater coils, condenser coils. For the weld inspection, we are doing this. So now NTPC has fully adopted this technique for replacing the radiography. So this is for the long seams of pipe. So in here they have adapted the two technologies, PAUT and TOFD. So just to do one scan, it will automatically record the data. So we can able to adjust the curvature also for seating arrangements. For the laser guided, to analyze the center line for the offset discrimination. And the another advantage is that in here you can able to see whether I am having a better coupling or not. Suppose if I am not having a coupling, so it will show you as a red color. So while doing it itself, we can able to identify whether I am doing a good data or a bad data. Now he is come back and he will do again. It will show you the speed also, how much speed you are doing. Suppose if you are doing a manual, it will show you the speed also. So now they are doing the inspection of circumferential seam, suck seam. So with the single scanner, we can able to use for long seam and as well as suck seam for different ODs. So these are all the automated scanners which can crawl in automated way and which can able to steer it. Suppose if you have a drift in your scanner, we can able to control with the help of joystick. So like this. So it will automatically crawl the job and it will do the inspection. And it will do the entire corrosion mapping or well scanning also. So these are all the typical techniques that we are using in our Boeings and composites. So we are doing for the thickness mapping, and suppose if any defect will be there, lamination, delamination will be there. So we are using. So our major clients is VSSE, ISRO, LPSE. They are using this technique only. Thank you.